I'm the awesome tutor, and today we're going to be looking at exothermic and endothermic reactions. Now, an exothermic reaction is when heat energy is released from the reactants to the surroundings. And because the heat energy is released from the reactants to the surroundings get hotter. Okay, you're releasing heat to the surroundings so they get hotter. And here we have an energy profile of an exothermic reaction. As we go up, the chemical energy increases. Now, as you can see, the products have lower chemical energy than the reactants. Why? Because heat has been released from the reactants to the surroundings, you have lost some of that heat energy. And so the products are made up of the reactants. And if the reactants lose chemical energy, then the product will have less chemical energy. And here, from the reactants to the products, is the change in heat energy, minus delta H. The delta means change, the H means heat energy. Minus because you've lost heat energy. You've lost it to the surroundings. That's why your heat energy and your chemical energy is lower. And here we have a peak. This peak is important because this peak is the activation energy. From the product to the peak is the activation energy. The activation energy, what is that? That is the minimum energy required for particles to successfully react with each other. But I will talk about that more in a rate of reaction video if I make one. So, now I'm going to move on to endothermic reaction. Okay, so an endothermic reaction is when heat is taken in from the surroundings to the reactants. And because you're taking heat from the surroundings will have less heat, and so they will be colder. Here we have an energy profile. As we go up, chemical energy increases, and as you can see, the products are higher than the reactants. The products have more chemical energy than the reactants, and that's how you know it's an endothermic reaction. So, here we have the change in heat energy plus delta H. The change in heat energy, it's gone up, and the peak, from the peak to the reactants, is the activation energy. Obviously, you will draw your thing with a ruler. All the way to the top. So why do the products have more chemical energy than the reactants? Because if you're taking in heat from the surroundings, you're going to have more heat than you did at the start. So that's why the products have more chemical energy than the reactants. Because remember, the products are made up of the reactants. And I'm just going to tell you one last thing about exothermic and endothermic reactions. Okay, so how do you tell which one of these reactions is exothermic and which one of these reactions is endothermic? Well, usually you will have one reactant and several products. If you have one reactant, then it's probably going to be an endothermic reaction. If you have more than one reactant, then it's obviously going to be an exothermic reaction. Releasing heat, taking in heat. Here I've used examples from the limestone cycle where they could give you anything in the exam. This has been the Awesome Tutor. Bye!